All right, so 4, 5, 4, 6, and maybe throw in a little 4, 7 at the end. All right, 4, 5. Right here, I want to make sure you guys all understand that we're using these 5 rules, okay, for congruent triangles. All right, so the first thing you got to do is label them. Okay, label the things that you have. I know that this side is congruent to this side, so right away I know that KG is congruent to LG, right? Why do I know that? Because it's given that they are congruent, right? So definition of congruent sides, okay? So when you are shown that they're congruent by that line, right, then you know that they're congruent. It's a definition of congruency, okay? So in the same aspect, wouldn't KJ be congruent to LJ? Right? Definition of congruency. Okay? Because they're congruent. So anytime you say because, we're going to say definition of congruency. Okay? So the next step, right, is we need another side or an angle or something. So can we find the side that they're sharing? Right? Are they sharing a side? So if we take a look, are they sharing this side right here?
Yeah.
Yeah, they are, right? So how do we say that GJ is congruent to JG? Do you remember that? Not transitive. There's 2 different ones. There's the symmetric, but there's also the reflexive. Okay? So, reflexive property, okay? And now we got to say, okay, we want to prove. Now we know that this is congruent to itself, right? Because it's the same thing. It's the same side. So now we have side, 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 right? We have a side, we have a side, we have a side, right? So we can prove that the triangles are congruent, but we have to write it correctly. So if I say that triangle KJG is congruent to triangle, how would I say the next triangle?
LJG?
Yes, LJG. So it has to go with those same sides. LJG. Very good. And then why are they congruent?
Because they're the same side.
Side, side, side. Yes. Side, side, side. So that's our definition of congruency. Okay? Alright. The next problem has these 2 lights shining in it. Like, one of them is this green light, right? And one of them, I think, was a red light on a stage. Okay? And so, what they wanted to know is, these 2 triangles, how can they be congruent? And one thing they said was that these are right triangles. Okay? That the stage lights were going perpendicular with the ground. Okay? And then also shining over. Okay? So, because they're perpendicular, we know right away that angle B is congruent to angle DBC, and then how come? Why? Definition of right angles. Because in this case, they didn't tell us that they were congruent, but they did tell us that they are both right. So there's a difference, right? So we can't use congruencies, but we can say they're congruent because they're right. Because we know that right angles are 90. And if they're 90, then they're equal. And if they're equal, then they're congruent. Does that make sense? So, definition of right angles. Okay? Alright, what else do we got? Well, we were given that EC was congruent to DB. So, EC is congruent to DB. And that's because it's a given. So they gave us something. That was good. So EC, right, is congruent to DB. Am I recording? Yeah? Okay. And that's a given. Okay? So now I have a side and an angle. And what they wanted us to do was solve it using side angle side. So they gave us a hint. Instead of trying to use, because it's a right angle, trying to go for that angle side side, or that, to prove that these are, the hypotenuses are equal. We don't know that they're equal. We have no clue. But what we do know is, this side is the same for both of them, right? So CB is equal to CB. Right? And that's called reflexive. Now I should look it up, because one of them is called reflexive and the other one is called symmetric, right? From the beginning of the year. From what I remember looking in the book last 3 years ago, it was always reflexive, reflexive, reflexive. They barely ever used symmetric, but in the beginning of the book we used symmetric. They seem to be about the same thing, so I'm going to re-look that up.
How come it would be BC like it was up there? Like, it was GJ, JG.
Oh, it could be. Yeah. I think it's better to say BC. Sorry about that. And I used to do CB is congruent to CB due to identity. But I think what the book has is symmetric, right? When they're identical, but then when they reflect, they're reflexive. Or it's the opposite. I'll relook at that. Okay? Alright. Now here's the thing. The reason why we're going from CB to BC, BC to CD is, in one way we're going this way, right? But in the other way we're going this way, and that's why we're saying, well, one is the other is the other. Does that make sense? So now I want to prove. Now I know I have an angle, right? And I have a side and I have a side. And technically I should have done the given first, so I would have had side, angle, side, right? Because what I have here is side, angle, side. Does that make sense? So my proof is that the triangle ECB is congruent to the triangle DBC. Why? Side, angle, side. So we don't have to prove them in order of side, angle, side. But what we do have to do is list them in the correct order. Even though this says ask, it's not saying angle, side, right? It's not saying angle, side, side. we're saying side, angle, side. You see the difference? So this triangle, we're saying side, angle, side. Then we're saying to this triangle, side, angle, side. And that's why we're coming up with side, angle, side, and not ASS. So even though we proved it in a different order, right, it's okay. We could have proved it with this first, then this, right? We could have started with the given like we're supposed to, but we didn't. That's okay. It's still a proof. It still works. All right? Does that make sense? We're good? All right. So let's move on to 4.6. Now 4.6, we're just using the other three. So 4.5 is going to be the first two, SAS and SSS. And then 4.6 is basically the other three, AAS, ASA, and ASS. Okay, or HL. Okay? All right, so with this one, we're going to look at it and go, well, what is this one using? Okay? And so what I know is, I know that this is a right angle, correct? So I know that that triangle or that angle ABC and angle CDA are right. Correct? Now, why am I going for the fact that they're right angles?
They're congruent.
Yes, they're congruent. But over here I said, hey, they're going to be congruent. But over here I'm saying, hey, they're right. Why am I doing the two different things? And it's because if I'm going to prove HL, I have to prove that it's a hypotenuse. Or, if I'm going to prove that it's angle, side, side, then I have to prove that it's right. You see what I mean? Angle, side, side only works if it's right. You can use angle, side, side. It's totally legit. But you have to prove that it's right. So, bingo, it's right. Now, I could go on and prove that the side opposite is a hypotenuse, and then prove that that side, that hypotenuse is congruent, right? But, so that would be the HL method. Or you can go with the angle side side method, which is, I think, easier, the method I grew up with, right? And that is, hey, I know these are right. Hey, I know these are congruent. So AD is congruent to BC. Why? Definition of congruency. They're showing me. Boom, boom. They gave it to me, right? You could say given, but I like to say definition of congruency because they're showing you that they're congruent with that symbol. Okay? So definition of congruent sides. Okay? And then the top one was definition of right angles, right? And that just, instead of saying given for everything, I'd rather have an explanation. Okay? Hey, it's showing me they're right, so I know that they're right. Hey, it's showing me they're congruent, so I know they're congruent. Okay? Alright. Then why do we know that this side is, why do we know that this is congruent? Why is it congruent to itself? Why does AC, why is it congruent to CA? Because it's the same thing, yeah. What do we call that? Reflexive. Yep. You're going to see a lot of reflexive in this chapter. A lot. Okay? So reflexive. Because whenever they're sharing a side, reflexive. Whenever they're sharing a side, reflexive. So one thing you're always going to look for is, are they sharing a side? Okay? If they're sharing a side, cool. I know that these are congruent. And now what do we have? We have a right angle, we have a side, and we have a side. So because it's right, we prove that it's right, we can say what? We can say ass. Okay? We prove that it's right, so we can say ass. Okay? Alright. Ass is only congruent if it's right. Can't say much. Okay? So only, and I love teaching it this way because you remember it better. Teaching hypotenuse leg, kids don't remember hypotenuse leg as much. But angle side side they remember. Okay? So what do I have? I have the triangle ABC is congruent to triangle CDA because that's what I'm proving. Why? Because it's ass. Why does ass work? Because it's right. Okay? And that works. Okay? And you can get away with that even on the state test. They cannot argue that. That is correct. That is absolutely correct. And even states in the book, we don't like you to do this, but this is correct. Okay? I don't know. It's silly to be. I'd rather kids remember it than not remember it. Alright, so 12. 12 takes in the stuff what we learned in chapter 3. Remember? Parallel lines? We know these are parallel. We know these are parallel because of these arrows. Okay? Alright? So what that tells me is that there's a transversal, right? Okay? And that means that this angle is congruent to this angle, correct? Why? Do you remember parallel lines? Interior, exterior. Are these alternating?
Yes.
So they are called
Alternate.
alternate interior angles. Okay? So this is a tough one. This is one of those. These are the ones that are going to be on your test. I guarantee you I'm going to throw something like this. Okay? So alternate interior angles. That means that what? That means that angle URT is congruent to angle STU. Okay. What else do I know? Right? Well, I better put that RU is parallel to ST, right? And UT is parallel to RS. And that was given, because that's what they gave us. They said, hey, these are parallel. They told you that in the book, if you read the book. So, okay, so we have to write that as a given. Okay? Alright. So then from that we can say alternate interior angles. Are there another pair of alternate interior angles? Right? Aren't those congruent? Right? And they're also alternate interior. Okay? So again, angle RTU, right? RTU is congruent to TRS. AI angles, right? All right. So we have a couple of angles, but we need a side. We need either angle, side, angle, or we need angle, angle, side. We need a side. Angle, angle, angle doesn't work for congruency. It works for similarity, which you'll learn in chapter 7, but it doesn't work for congruency. So we need a side. So what do we always look for? What do we always look for? Come on, people. Sharing a side. Always. Always. This whole chapter, I guarantee you, sharing a side. If you look for sharing a side, half of your problems will be solved. Okay? So what side are they sharing? RT. Yeah. If you take a look right here, boom. This triangle right here, right? And this triangle right here, okay? Those two triangles are sharing that side RT. So RT is congruent to RT, or to TR if you want, okay? Why? Reflexive. Whew. Okay. Now what? Now what? Is that enough? So I know that this is congruent. Is that enough? What do I have? Take a look. I have this blue one, right? Boom, 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 and it goes dink, 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 dink. And then I have this purple one, and it goes boom, 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 and it goes dink, 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 dink.
Angle, side, angle? Is that what we're
Yes.
looking for?
Yeah.
Oh, okay.
Exactly. Angle, side, angle. That's it. Okay, so we know that the triangle RST is congruent to the triangle TURY. Angle, side, angle. That's it. A lot of work, right?